Okay, good afternoon. Is it afternoon or evening?
Nighttime.
Good night. I can't say that, you're all gonna leave. Welcome to OCHEM 2. A lot of familiar faces, some new faces. Good to see you all. I want to take a second to introduce myself. My name is John Flood. I'm excited to be your instructor this semester. This is my 7th straight semester teaching OCHEM 2, I think. It's been a long time. You know, one of the challenges about teaching a course so many times is the material just gets really easy for me. So I'm going to try to forget that it's really easy and remember how hard it can be at the outset when you're learning it, and be on the same page as you guys so that you guys are able to absorb as much as possible from this class. A little bit about me. I'm from Wisconsin. I grew up in a small town with a big family. I went to a very small school. Little fun fact, I have more siblings than I have graduating classmates. I graduated in a class with 6 classmates, and I'm from a family of 8, 7 siblings. I went to college at the University of Wisconsin-Stevens Point. I got my bachelor's in chemistry there. I knew that I liked the challenge of chemistry. I didn't really know what chemistry could do for you, but I loved teaching too. And I set my sights on getting my PhD so that I could become a college professor, not have to babysit kids in high school. And then I got into grad school. I went to the University of Colorado Boulder for my PhD. I got into my first full year of doing research. I got into my first 3 months of doing research, and I found out I hated it. I had no passion for it. I was drained of all my energy, and I think it's because I had no classroom to engage with, no students to engage with. It was around that time I found out that my department would give me a master's for the work that I had done along my PhD. So I dropped out of my program, took a master's degree, and I started here teaching at SLIC, going on 5 years ago. 5 years ago this summer. Started here as an adjunct, and then I kicked and screamed and got my way into a full-time position so that I can have as many classes as possible. And so I'm doing what I love to do. I'm exactly where I wanted to be, where I wasn't sure I could ever get. Being at a community college for me is way better than being at a 4-year institution, because my full-time job is you guys, taking care of these classes that I teach, and I love it. So my goal in this class is not to make you fall in love with chemistry. It's not even to make you enjoy the class. My goal is to get you through the class so that you get on to doing the things that you want to do. Raise of hands, how many of us are in here going to medical school? Good number. Pharmacy school? A few. Dental? Couple. PA school? Oh, maybe PAs don't need OCHEM 2. That might be a thing. I don't know.
They don't.
Bummer. Engineers. Any engineers in here? Yeah? Couple? Chemistry majors? Oh, that's more hands than I'm used to seeing. That's great. Anybody that I missed? Engineering? Oh, vet science, of course. How could I forget that? What else?
Here for fun.
Yeah, I usually get one of you guys here for fun. Crazy. Sometimes you'll find out that it's more than just for fun. I had a student in the fall that took OCHEM 2 just for fun, and then found out the program they were applying to actually needed OCHEM 2 as an elective. It worked as an elective, so you might get lucky.
I'm not sure.
I like to teach this class not to be a stickler about the chemistry, but to explore the world that is around us. I like to make it feel applicable. We'll have some assignments to help you apply what we're learning. But I also like to explore how interesting it can get. So we've got a set schedule. We're going to try and stay on pace, and we'll learn a lot of different reactions this semester. Oh, sorry, I got distracted. This is my partner on the left. He and I are big skiers. We got out last week right after the snow, which is what you see here. These are our 3 cats. On the left is Yasmina. That was my partner's original cat. On the right is Sky. She was my original cat. And in the middle is Asuli. That's the cat we adopted together. It really looks like they love each other. They hate each other's guts. And this is the only time that they ever live in peace. Actually, you can see Sky is looking at Asuli. She's about to swap him. But this is my family on the right. This is actually missing my youngest brother who lives in Thailand, and then another brother who lives in Minneapolis, and his wife and his 3 kids. So this is a small group of my family. Let's talk a little bit about our course. I have to apologize because some of you actually got started on Canvas yesterday, and then I realized I made a mistake in what I posted about Canvas, and I had to reset, and most of the dates are messed up, actually. Yeah, I apologize about that. I need to go in and do the dates still. But I erased a few assignment grades. I think there were 3 students that had turned in a total of 5 assignments. Sorry. I think the good news is the reset that I did brought in the updates that I made in the fall. Whatever I did before, it didn't actually bring in all my updates. So if you got started on things, you might have to restart. But you'll also, if you've taken my class before, you'll also see that I've redone my homepage. I have a bit of a different look. The college has an accessibility deadline coming up in June, and my homepage was not considered accessible. So I'm revamping and reorganizing. So let me know what you think about this new format, especially those of you that have played around with my page before. We've got our schedule posted right here on the homepage. I like to have it pop up for you right away so that you can never miss it. What I have here are all of our unit tests shaded in blue so that you can start planning now for when you're going to take those assignments. Our midterm is posted here. We're going to do that in class in this room during our class period. And then our final exam is also posted on here. So this is a great roadmap for you for the semester. This is my week-to-week schedule. If you printed this out more than 20 minutes ago, it's outdated. I had to fix my office hours. Oh, and there's something I didn't put on there. I have a faculty senate, which sits right here twice a month. And so I should have blocked that out, and I forgot to. This is my week-to-week schedule. It might look like I don't have a job, like I'm a part-time teacher. I'm actually on something this semester called Course Release, which allows me to work on developing a new course, and that is CHEM 1250. Is anybody in here taking CHEM 1250 with me? Yes, you are. What's your name? Milena. Okay. I recognized that name on there, but I wasn't sure who you were. Great to have you. Anybody else that wants to join us in CHEM 1250, you're more than welcome to. It is called Introduction to Instrumental and Chemical Analysis. It's either a 4 or 5 credit course, but it's a lab lecture mixture. And we're basically going to explore a different instrument every week, the components, the theory of how it works, and then we're going to use it and run it and interpret the data. I'm excited for it. It's going to be a fun class, but I'll be spending most mornings every day working on developing material for that class. If you need to meet with me for student hours, I've got my times there for you. I've tried to spread them out to make them more accessible, but I do recognize a lot of students that sign up for a 5 p.m. class are not available for midday office hours with their professors. So if my times don't work for you, you see that I've got a fairly flexible schedule, reach out and see if there's another time that we can make work for office hours. This little QR code will open up an email to me that is pre-formatted to ask about a day, a time, and a place to meet with me for office hours. However, I would rather that you that you message me regularly on Canvas rather than through my email. I prioritize my Canvas messages over my email. My email gets notifications when I get a Canvas email, a Canvas message. However, I also get about 1,000 other emails every day, and it gets very cluttered. My Canvas inbox stays less cluttered, so it's easier for me to prioritize you there. All right. You will be going through this first things first page, which is going to point you to the syllabus, take you on a syllabus quiz, get you situated with your homework, and then show you some of these useful tools that I want you to have quick access to throughout this semester. I am going to pass out this document, or this handout. On it, there are a few different sections. We're going to start with just the first one. What I'd like you guys to do in groups is discuss concepts that are related to organic chemistry. So what you can do individually, if you'd pass those down this way, please. What you can do individually is list out a couple of things you're excited about for this course and a couple of things that you're worried about for this course. And then get to know the people around you. Introduce yourself, share your names, share what your majors are. And then work together on drawing a concept map. I want this to have no more than 5 ideas that you think are related to the concept of organic chemistry, and then we're going to talk about them together and draw a more comprehensive concept map on the board. So take the next 6 minutes to work on this with the people around you. Would you do me a favor and just for now at least, that'd be great. Thank you.
Anxiety medication. Because I studied that molecule. Poor CHEM.
You're going to pick a new one this spring.
What is this?
Magnets, of course.
Thank you.
You're welcome. Oh. Depends on if you're good at math or not. PChem could be pretty easy.
If it's not like geometry, I'll be fine.
Well, it's the math behind the geometry. Like you derive orbitals. Good. Yeah, you like math then?
Oh, I mean, I'm not terrible at it.
Oh, well, there's a lot of Calc 3 in it, but like just partial derivatives.
Like, I'm still gonna get my associates, but for my bachelor's, I have to.
Oh, you know what? I didn't tell you guys what a concept map looks like.
Short phrase for that.
You're welcome.
Do you need a pen to borrow?
That'd be great.
I don't think I don't have that in pencil though. Yeah, that thing is massive.
Hey guys, do you want to know what a concept map can look like? Sorry. What I want you to try and envision is OChem here in the middle, and then think about 5 different things that are related to OChem. And just just be broad. Sometimes these things are related to each other too, but come up with 5 different ideas together.
Does that have flowers on it? Like, that'd be perfect.
That would probably be helpful.
Thank you so much.
Two things you're excited about, summer.
Sun. This class gets me to the summer.
Amen. You know, it's still light out. It's still light out.
For a minute.
At the end of fall semester, it's like pitch black by now.
But it's gonna be pitch black when I walk outside.
You're right. And but you'll never know.
That's true.
It's a functional groups.
There you go. Has it been a year and a half, Ozzy?
I know that one. And this anti-freeze.
No, yeah.
It's fall.
Well, no, 'cause I finished the final last spring.
Well, yeah. But it was fall of
I think so.
24. Wow.
Yeah,
Crazy.
I know. You're like looking at me like, what are you doing? Like, I know. What am I doing?
What are we all doing? What are any of us doing?
I didn't do too bad on that quiz on the the final, yeah, but holy shit, that was your little quiz for the
OCHEM 1 review.
yeah, I didn't do.
Good.
I think the
Did it
only-
feel like a refresher?
Yeah, it was nice, but the only thing I think I really this is gonna make you laugh, but I totally forgot that Oro.
Aereo.
Oh, Aereo.
Yeah.
I was like, oh, I remember talking about this, but I don't remember anything about it. But you know what I remember? Just butane, and that's the one that stuck with me the most because I was like, he did this so many times. I cannot tell you how many times I read that molecule. I was like,
You're going to notice a very different course layout.
oh really?
Because when you took it, there were 3 midterms in the final. We've got 1 midterm and a final,
Okay.
and then 5 unit tests.
See, and I don't know what you're gonna.
A unit test is just, we'll talk about it, but it's just less material and more often. So it's like a check-in before, it's a mid-stakes assignment. Homework is low stakes, unit tests are mid-stakes, exams are high-stake assignments. So
I'm excited to see what you've got.
I think it's going to feel better.
You know what? I think I'm more confident in this class. I'm taking the lab though. I haven't taken a lab for a minute.
You'll be okay. Do you have Ty or Chris?
Chris. And I walked in, I was like, bro, like you and I are gonna click.
Yeah, absolutely.
I'm like, I probably come to you with questions because I'm already like.
Well, do it. I wrote it. All right. Thank you, guys. Let's talk about what you came up with. What are some concepts related to organic chemistry? Carbon? Yeah, start off strong. You guys know the definition of organic chemistry? You all took OCHEM 1, right? You have no idea what it means.
Chemistry involving organic molecules.
It's a cyclical definition, I think.
Everything carbon-based.
It's not actually everything carbon-based. It is hydrocarbons. So organic chemistry is the study of hydrocarbons and their derivatives. So I would say, yeah, carbon is a good connector to organic chemistry. What else you got?
My work in the pharmacy, chemistry relates to OCHEM specifically.
Absolutely. Do you mind if I expand that and say pharmacy/medicine? All medicine. You know, I like to say that biology is just applied chemistry. Really, what is an applied chemistry? Physics is just applied chemistry. I mean, you're talking about matter at some point, aren't you? Biology is applied chemistry. Engineering is applied chemistry. Anything you're going to go into that involves matter, it's just applied chemistry. What else do we got? Food. All right. Can't talk about organic molecules without what you're going to eat. You guys ever seen the chemical ingredient list of an apple? It's really big. It's a very long list of organic molecules mostly. It's not just one thing. What else?
We talked about reactions.
In our class, reactions will be most of what you do. There will be some parts of the class that involve ranking molecules based on conceptual ideas of how reactive they are, how acidic they are. But a lot of our class is being able to predict the product of a reaction, provide a reagent to let a reaction proceed, or solving a multi-step synthesis by thinking about what reactions can get you from A to B. Reactions are a huge part of our class for sure. What else? Indigo. Energy. I love energy. Did you know that? 100%. In fact, I'll draw you guys a few energy diagrams this semester to help you understand reactivity and why certain reactions proceed the way they do. So I'm actually going to link these two because reactions and energy really go hand in hand. Can we get one more?
I was thinking like bodily processes like digestion.
I agree. Could I put that here? Metabolism? Because it's very much related. All of those bodily processes that you've got going on, they're going to shut down eventually if you don't have any food. And a lot of them depend on the food that you put in. I was just having a conversation yesterday with Laura Harris, a professor in the geosciences. And we were talking about the magnitude of molecules that you need in your body. You guys know how many base pairs are in your DNA? How many? 400? Oh, there's 4 different molecules. Yes, 4 different base pairs. But in a strand of DNA, there are 8 billion? No, more or less? I think it's 8 billion, but if no one's going to correct me, then we'll just have to leave it with a question mark. Sorry, I'm not a biology professor. Let's say there are 8 billion of those base pairs in one strand of DNA. Every cell in your body has your DNA, your full sequence of DNA. You know how many cells are in your body? 1 trillion or so. So 1 trillion times 8 billion, you're looking at 8 billion trillion of these individual nucleotides in your body. So where did you get them all? Where did you get 8 billion trillion? Not to mention your cells die off and they get eaten up and disposed of, and you've got to replenish that stock. Where does that come from? Well, it comes from the food that you're eating. All the DNA inside of all the cells that you're eating contains all these molecules, most of them organic, and your body reconstitutes them, puts them where they need to be. Insane number of molecules. And the fact that it's all based on just four molecules repeating, crazy. Sorry, we got a little distracted. Let's do one more.
Functional groups.
Yeah, that's what I was looking for.
I already said that.
You said it, but not to the group. If I could say one thing to you at the start of the semester, it would be learn your functional groups. You will not do well in the final if you do not know your functional groups. You will have a hard time learning all of the different reactions if you do not know your functional groups, because the reactions are the functional groups. We're going to learn how to make aldehydes, how to react with aldehydes, how to make ketones, how to react with ketones. If you don't know the difference between an aldehyde and a ketone, it's going to be really hard to understand why this reaction makes an aldehyde and not a ketone. So how can I help you learn your functional groups? I want you to come to our homepage, click on these. Oh no, did I do something wrong? I might have. Oh, here it is. On our homepage, click on this class resources, download this. Download it today, print it off, keep it with you all semester. This is a document I made the first time I taught OCHEM 2. I got feedback from an OCHEM 1 student who said, I just wish I had a list of all of the functional groups you wanted us to know. And I said, that sounds like a really hard task. I'm on it. So I made this. It's got a generic example of what a functional group is and a specific example of a molecule with that functional group. True or false? Every molecule has only one functional group. Very false. So I've actually given you a few molecules. Here is a peptide that has an amine, a carboxylic acid, and an amide, but I'm using it as an example of just the amide in that case. Learning how to recognize functional groups is really hard, so you'll have an assignment on it so that you get practice doing it. So right away, get to know your functional groups. It's inevitably at the end of the semester that I have students asking me, I'm struggling with this or that. Okay, well, do you know what functional group this is? Okay, that's a good place to start. Go back, study your functional groups. Can I say it a few more times, or is it setting in? Learn your functional groups. All right. Thank you guys for doing that exercise with me. It's fun to see all of the different ways that organic chemistry applies and all of the different things that tie into it. And that was, you guys made that. I didn't even have to make that. All right, here's what we're going to do next. I want you guys to explore the syllabus a little bit more. Just so you know, the syllabus is right here on Simple Syllabus. So if you've got your phone or your laptop or a tablet, I want you guys to work in your groups again. Those people that you already introduced yourselves to. Work on writing down 3 things from the syllabus. Things that you have questions about, things that you are excited to see in the syllabus, or things that you are confused about, that you thought you would see in the syllabus but don't see. While you do that, I'm going to rip up some paper and hand it out for a little attendance sheet. I'm going to put some information up here that will help me get to know you guys better. So when I hand out that little slip, if you'd put that information on it, and then I'm going to collect it to keep attendance for today. So let's spend the next 8 minutes or so diving into the syllabus. Gonna poke your eye out, Ella.
I was like, you just picked up my cheeks.
Sorry. It's a really small one. You guys working as a group or you're just hanging out as loners together? Oh, looks really engaging. You're welcome.
I'm trying to remember.
And maybe that was just because of.
I guess I'll get leftovers. Yeah. He didn't email us in last month. Yeah.
I'll be weird question. So
Yeah.
we need the organic chemistry book, right?
Also, I was like,
No,
I figured this is just the same.
like not need.
Okay.
It will. It's a super useful tool.
The organic chemistry
Textbook.
textbook.
Yeah, it is listed as the course text, but there will be no homework assigned out of it. The reading, the pre-reading quizzes, they can be done using any resource. Like they're not specifically taken out of a textbook.
Well, because I was going to ask if we needed the solution manual, that would have. Okay, so.
Not for my class. No. Our course lead does require it. I mean, just to make it easier because he assigns the homework problems from it.
Who's your course?
Ron Valcarsi.
Yeah, that's what you want, because he was my professor.
You had him for OChem 1. You'll see a pretty different setup between my course and his.
Yeah, like I said, I've heard.
Yeah. And I think he has 2 sections of this class. But it's not going to be unuseful, especially if you still have access to his website. And if you find what he does as like required homeworks and you do it as practice, you've got the solutions manual, which is going to give you a leg up.
Well, see, that's the thing. I don't have the solution.
Oh.
That was the main thing I was like.
Good. Because I tried to tell people not to spend their money on it because it's so expensive.
Because I have access to the reading, but it's just like the solutions manual. And
Yeah, you won't need it.
Valcarsi was nice enough to allow us to like take pictures of the solution manual, so that way we can kind of bypass it.
Mm-hmm.
So that's what we did.
Yes, unfortunately, there's no easy way out on homework this semester. You've either got to get the problem right or you don't get the points for the problem. There's no solutions manual to copy the answers out of. But in my opinion, that means that you will be working on learning. I've actually watched students copy answers from the solutions manual wrong. Like I've watched them make errors in their copying. What are they learning? They didn't know what functional group they were writing down. So I think there's some pros and cons to both ways, and I've had to pick one way, and this was what I picked.
Thank you.
You're welcome. Hi. No. Sorry.
May I ask you anyways?
Yes. But ask it anyways.
Would you be willing to write me a letter of recommendation for veterinary school?
Yes, I'd love to. I'd like to have a sit-down meeting.
Okay. Should I email you to schedule that?
Yep.
Okay, I will do that.
When is it due? Summer? Spring? Yeah.
I don't actually know.
Sure.
I will find out.
Which means probably not soon.
Well, yeah, probably.
We'll find out.
Yeah, we'll find out. And
Yeah,
then-
email me.
Okay.
And maybe do an actual email instead of Canvas.
Okay. So the QR code.
That works.
Okay.
Yeah, my email is real simple. john.flood
Okay, yes.
at slick.edu. You don't even have to put in the Bruin mail thing.
Isn't that in the
Yes. Yes, it is. Good job.
It's not. I know, it's like J Flood 3.
Oh, yeah, I have 2 emails. They go to the same place. But what's easier to remember? jflood3 at slick.edu or john.flood?
What is Spec doing back in this?
That's great.
What are you talking about? How would you know what a molecule is without it? It's going to be very simple. It's truly not as challenging as it is in OCHEM 1.
No, I mean,
It's not as prevalent as it is in OCHEM 1. And it's actually, there's more bonus points on the exams from spectroscopy than there are graded points.
well, you actually explained it a lot better once I actually got it. I'm a little worried about the mechanisms on the second part.
On the what?
On the second part, the mechanisms. I remember we had to like.
Oh, we're going to be doing mechanisms all semester. But we're going to narrow in on them. I've got worksheets to help you learn the steps.
No, that's alcohol.
You're getting started on the homework already? Wild. Good point.
Thank you.
Yep.
Oh, that's so funny. I did it exactly. Oh no, I had an exclamation point on that one.
Kiara is not joining us, is she?
No, she doesn't need it for her degree.
Bummer.
It is a bummer.
Yeah. I saw her earlier, but she was in a conversation with someone, and I didn't want to interrupt. But I'm going to be seeing her later this semester anyways, writing her a letter. Oh yeah, and that. Ella, do I still have your exam from the summer?
Thank you.
Did I ever get it back to you?
My midterm, yeah.
Oh, okay. So I still have your final. It's upstairs in my office then.
I took my final on my iPad.
Oh, you're right. So did I ever email it back to you? I'm kind of like outing everybody that's been in my class. Yes, I'm going to post it.
Thank you.
You're welcome. I'm going to post it to Canvas right after I change all the due dates on Canvas so that you guys can practice for the baseline knowledge that you should have coming into this class. Yep. As well as the midterm. I'll post the midterm on here too. All right, are you guys ready? Sorry. I never gave you one? How come?
No, the packet ones. Is that what you're just passing?
Oh, that's the finals. For
Oh,
last
no,
semester.
sorry.
I'm stupid.
No, that's okay. That was totally random. It was like a handful of people getting it.
Okay, I was like,
You have this though. Oh, good, good.
I'm good. I lied.
If you haven't already, if you just fill out on this little piece of paper your name, especially what you want me to call you, although if that looks a lot different than what it shows up on as Canvas, maybe you can show me both and then circle your preferred name. Your pronouns, your career path. I gave you guys some fun facts, so be brave. Give me a fun fact if you can. I can't force you. All right. While you do that, let's talk about the syllabus. What stood out to you as important, confusing, missing?
My group told me that the unit tests you're gonna be able to take those at home.
Yes. Yes. Unit tests are 35% of your grade. There are 5 of them. These are no lockdown browser, no required place you need to be, but there are 2 parts. Part A is multiple choice. That's usually 10 questions, but it's not always. You get 60 minutes to take part A, and then you get to see your score, and you get to see which questions you got right and which questions you got wrong. You don't get to see the right answers to the ones that you got wrong. Then you get to take it again. I'm looking for mastery. I'm looking for you to reflect on the questions you got wrong on your unit test, study up on those, and then take it again and ace it. But it's not going to be the same questions on your second attempt. I've built these unit tests to essentially have a question for each learning objective, each concept I want you to be able to master. And that means that I've got question banks around that learning objective. So when you go through the second time, you're hitting the same learning objectives, but you're likely to get different questions for them.
Now, are you going to do them like kind of like how like we're learning like building from like the oldest stuff to the newest, or are they going to be random?
Generally it does go from oldest to newest, yes. But I don't want to say that's always true. It can definitely be scattered. So 60 minutes per attempt. My recommendation is take the first attempt early on and then study up. Take the second attempt the next day. After you've done both attempts, I recommend taking part B. Also 60 minutes, but this is short answer. You only get one attempt. You will need to upload an image of the work that you've done to the Canvas quiz. So sometimes that means taking a picture with your phone, emailing it to yourself, dragging it in. I understand that that becomes cumbersome when you're in a timed quiz environment. So if the quiz times out and you send me an email or you upload your files as a comment on the quiz, I'm happy to give you the benefit of the doubt as long as it's within a reasonable time frame. If you email me the next day and say, oh, I totally had this done, but it just timed out on me. How do I know you haven't been solving that problem all night and you just finished? I don't know. So I'm happy to give benefit of the doubt, but try to be quick about uploading your answers there. This is what I call a mid-stake assignment. You're going to have 5 of these throughout the semester, touching on several of the sections at once. But it's 35% of your grade distributed across 5 attempts, 5 tests. So it gets balanced out. The high-stake assignments are your exams. You only have 2 exams this semester, but they also add up to 35% of your grade. This is an important thing I want you guys to know, and I think you probably did see this. What do you get to bring with you on the midterm? One-sided sheet of paper as a cheat sheet. What is important to know about that cheat sheet?
Isn't it 30%?
The exams are 30%? I don't know what else the other points are then. Something is going to be a different number than I'm not expecting. About that cheat sheet, it needs to be handwritten. So a lot of you, I know, take notes on your tablets. That doesn't mean handwriting on your tablet and then printing it. It means pen to paper to make your cheat sheet. No printing things and taping it on there. That's to have some sort of equality between all cheat sheets. The final exam, you get to have a double-sided cheat sheet. One of the reasons I make the final exam have twice as much of an opportunity to cheat is because the final exam is cumulative and it's longer. So you should have more space to write stuff out. Some people like to keep their cheat sheet from the midterm and then just write a second sheet for the second half of the semester. But one way that I encourage you to create your cheat sheets is during the unit tests. So unit tests, you're allowed to have notes. I strongly discourage you from using the internet on the unit test. Because if you don't know it on the unit test, and if your notes don't tell you it on the unit test, how are you going to prepare for the final using your notes? So using the internet on the unit test might get you straight A's, and it might really hurt you by the time you get to the exams. I would recommend on the unit tests, start building your cheat sheet. Start writing down things that are important. Start writing down examples that are meaningful. Build a mini cheat sheet for Unit 1. build a mini cheat sheet for Unit 2, build a mini cheat sheet for Unit 3, and then when you get to the midterm, combine all of those cheat sheets together. And the last thing that I have to say about this cheat sheet is that it is not an advantage. I am the only professor in the chemistry department that allows cheat sheets on my exams. The others are actively pushing me to stop allowing cheat sheets. They think I'm hurting you and your learning by allowing cheat sheets. So I'm telling you now, I'm not giving you an advantage by giving you a cheat sheet. In fact, this is the biggest risk that I'm going to gamble on your grade, is allowing you to have a cheat sheet. This is a huge risk. That's because some of you are going to build your cheat sheet the day of the midterm and the day of the final. And you're going to think that bringing in all that information is going to let you get an A on the exam. And you're going to find out that none of the information looks like the questions on the exam. And without the skills that come from knowing that material, you just don't have what it takes to do well on the final. So don't lean on this as your way of doing well on the final. Instead, take advantage of the idea of building a cheat sheet. What you should do is revise, revise, revise. And you're doing that by starting early. Build that cheat sheet with the unit tests, and then revise that information by the time you get to the midterm. And then revise that again by the time you get to the final. Keep revising what's on there. I asked my biochem professor when I was in college why he allowed cheat sheets in the most challenging course in the department. Nobody else allowed cheat sheets. He said it didn't affect student grades at all. Before and after allowing cheat sheets, his averages all stayed the same. But he noticed that students who did poorly on the exam would spend most of their time looking through the cheat sheet for information that just wasn't there or that they didn't know how to utilize. And the students that did well on the exams never looked at their cheat sheets because they knew what was on it. The only way to know what's on it is to spend time with it and to build it lots. So I want to talk about that because it's the most dangerous part of my class. Anything else you guys want to talk about from the syllabus? What else do you see? Meaning you don't want to take it while you're on a trip? Yes. It won't open early, so you're going to need to message me so that I can manually unlock it for you early. But yeah, I'd be willing to do that. It's dangerous because a lot of times we learn material the day before the unit test opens. And I do want to point out, the schedule again shows you what days the unit test will be open during. I do try to make sure that you have at least 2 weekdays that you can work on this, because I know some of you have busy weekends working. So you've got Fridays and Mondays that you can take advantage of to work on this as well as the weekend. But yeah, reach out and we can talk about opening it early.
Do we need the physical textbook for this course?
You do not need the textbook. I'm required to say that it's the course textbook, but even our course lead for organic chemistry doesn't ask his students to buy the new textbook. He encourages his students to buy outdated textbooks because they're cheaper. So I don't assume ever that we're all using the same textbook. And quite honestly, most organic chemistry textbooks are the same. They all cover the same material in the same way, in the same order. They're all very similar, so any textbook is a good textbook. I've got a link to a bunch of external resources that will be useful this semester, and one of them is actually a free online textbook. I'd recommend using that textbook because it has a control find function. You can search the entire textbook for certain words. You have pre-reading quizzes. Those pre-reading quizzes are not really drawn from any one text. In fact, I mean, I don't want to tell you this, but I didn't read my organic chemistry textbook when I was in college. Who does? You will. That's who, because it's really useful. However, if you were to take these pre-reading quizzes, which make up a small part of your grade, if you were to take these pre-reading quizzes using the internet, you would likely find all of the same answers. So then why do I require these pre-reading quizzes if I don't even fully expect you're going to be doing the readings? Because one way or another, I want you to get questions in your head about challenging concepts before you come into class and we cover them. That means that you can come in wondering, what did all those weird words mean? And what was I looking at with those reactions? And then we can talk about it, and you'll see answers to those questions start to come up in the lecture. So the benefit of doing a reading before class is to develop questions that can be answered in the lecture. Some people don't necessarily prefer that, and they'd actually rather flip it. They'd rather come into lecture, hear all these confusing words and see these confusing things, and then go into the textbook and look at examples and get answers that way. And the pre-reading quizzes help them connect the dots between what they're reading and what they're doing in class. So flexibility there with the textbook and how it relates to the quizzes. What else? Unlike the math department, the chemistry department does not have a minimum grade on the final needed to pass the class. I've had students fail their final exam and pass the course. Not necessarily with a high grade, but a letter grade, you know. And that is because the work you put in throughout the semester shows the learning you're doing. The fact that you don't perform well in the final exam does not necessarily mean that you didn't acquire learning throughout the semester and show it. Imagine if your unit tests were 100% and your final was 50. Should you really fail the class? Well, maybe. You could have cheated on the unit tests, I guess. Anyways, you can still pass while failing the final. It is a weird paradox, but that's the point of all of this adding up together. Anything else? Absolutely. So I should have emails from the ADA office about who has testing accommodations. And what I'll do is actually email everybody individually and ask how you'd like those accommodations made. Some people prefer accommodations to be at the testing center, and some people don't like the testing center for their accommodations. So I'm going to try and work with you guys to see what options are best. But if you have accommodations and you want to make sure that you get them, don't hesitate to reach out. I'm happy to talk about it.
Are late submissions on active penalized?
Let's talk about Active a little bit. Active is your homework platform. And you have already paid for it. So Active is 25%, right? Oh, yeah, I guess I messed up yesterday when I put these both on my OCHEM one. Anyways, there is no late penalty, so you can turn them in. The hard deadline for all assignments, actually, the hard deadline is May 5th at 5:50 p.m. Why? That's when your final exam starts. And there is no point in turning in anything after you've taken your final exam. I won't accept anything after you've taken your final exam. That's the whole point of the semester, is to prepare you for the final. So homework, hard deadline, they all have due dates that correspond with when in the semester I expect you to turn them in. So you will get those prompts to be working on them, but you're never penalized for turning them in late. You have 15 attempts at every problem. Boy, don't use 15 attempts. If you get to like 8 attempts on a problem and you're still not getting the right answer, take a screenshot of it and send it to me. Because it could be that active is just confused about what you're doing, and it's a perfectly reasonable answer, and it just isn't accepting it. 9 times out of 10, it's lone pairs. So, and the feedback that active gives you won't actually even point out lone pairs. I know a number of you have used online homework before and generally don't love it. That's okay. I have in the past made my own homework assignments, handed them out to students, collected them, graded them, and given them back. I found I wasn't ever really giving feedback. I was just marking right or wrong. What I want to do is spend my time giving you feedback rather than just saying whether you did it right or not. So I have offloaded the work of grading homework to active. Active will grade it and give you feedback. Again, its feedback is not always correct, but at least most of the time it is giving you some direction on how to fix your problem. Instead, I'll be using my time on the unit tests, giving you feedback there, saying how you're doing on the learning objectives, how you're doing on the more challenging written work. You've already paid for active in your course fees, so you should be able to just create an account, log in, and get in for free with the access code. Yeah. Actually, I want to show you guys a little bit about Canvas or Active. You will have an introduction to Active assignment that will get you familiar with some of it. There are these practice. This is going to look different on my end than it does on yours, but there are some practice problems for every section if you want to do more practice. But you'll be doing very little mechanisms on Active. I have never found an online platform that is good at doing mechanisms. Also, you will not have an online software to do mechanisms on the final or on the midterm. You will have to show mechanisms by hand. So you will have separate homework assignments.
Next question. Okay, sorry, I'm gonna interrupt. Are our test questions gonna be what we practice?
I mean, I don't take these problems and put them in the test.
I know, but like, are they gonna be similarly built?
Yeah, multiple choice, predict the product, give the reagent, show a mechanism, solve a synthesis. I would say the exams and midterms will look a lot more like the unit tests than they do the active. And they'll look a lot like the written work. The active will look differently, but that's because I wasn't able to write those problems.
Yeah, that's 'cause I got your handwritten ones. I got familiar with your test because of that.
So here's a good resource for you. On this home page, when you click on the class resources, I've got this work through practice problems. I have all of my old OCHEM 1 homeworks, all of the answer keys, all of the supplemental work that went along with the homeworks and the answer keys. I have the same thing for OCHEM 2. It says study materials. That's misleading. It's just practice problems and PowerPoints. So you want to see questions that I wrote with my style and do homework problems like that? Go to those links, go to those modules, and find the relevant homework. I revamped my course about 1.5 years ago, which is when I stopped doing these homework problems. So sometimes the collections or the names or the types of problems that are in them are different than the names and the collections that we do now. So just find the problems that you want to practice on and do those practice problems. Ignore the ones that don't apply to what you're looking for. Really good useful resources. Most of the time, the students that do the best in the class have gone through all of these homeworks and they've done these practice problems. So take advantage of it. Not graded, but very useful. Okay, sorry, the written work. The written work is because Active is very bad at helping you practice your handwritten mechanisms. And active is really bad at helping you solve multi-step syntheses. So I will give you guys a lot of feedback on your written work, your synthesis solving and your mechanisms, because arguably those are the most challenging parts of this class. I will also give you a lot of feedback on your unit tests on the written work, on the short answer, the synthesis and the problem solving, the synthesis solving, the mechanisms and the synthesis solving. So do your written work. It's the same deal. It's not due until the final exam starts. But if you don't practice the mechanisms and get my feedback before the unit test, then you're going to be doing the mechanism for the first time on the unit test. You're going to find out whether you're good or not at the mechanism when it's too late on the unit test. Do the written works, get my feedback, and then go on to the unit tests. I want to give you guys an example of what this written work looks like, because I don't want you to be scared about how long it is. This is your written work for OCHEM 1. That's it. I want you to show me 3 mechanisms. You'll notice that they are different number of points. I want to come in here and make sure that these points are corrected. I have established a point system. I don't want to screw it up, but for mechanisms, the number of points will be equal to the number of steps in the mechanism. We're going to learn a lot of mechanisms, but you have already learned mechanisms like SN1 and E1. How many steps are in SN1 and E1 mechanisms? They share the same number of steps. 1. SN1 and E1 mechanisms are one-step mechanisms, like for the most part. So that would be a 1-point problem. I'm sorry, I was wrong. Yeah, sorry. I was thinking SN2 and E2. Those are 1 step. SN1 and E1, minimum of 2, sometimes more if they have carbocation rearrangements, sometimes more if they have protonation or deprotonation steps. So SN1 and E1 could be anywhere from 2 points to 4 points, depending on the number of steps. I break down those points then into having the correct structure, showing the change correctly, and having the arrows correct. So half of the points in a mechanism come from having the electron arrow pushing done correctly. Half of the points in a mechanism come from showing the structure correctly. If you skip a step, well, you just lost that whole point because you don't have the structure and you don't have the arrows. If you have the arrows right, but you draw the structure wrong, then you lose half the points because at least you showed the arrows correctly, but you didn't understand how those arrows should be interpreted. If you can give me all of the structures in a mechanism without the arrows, you earned half of the points. You know what the structures are, you just don't know how to show them interchanging using electron arrows. I'm going to do something similar with synthesis, where the number of points is equal to the number of components. That is reagents that are needed and intermediates that should be shown. So let's say that I want you to get me from A to C. You'll need to come up with reagents to make B and reagents to make B into C. That's a 3-point synthesis. That means I'm actually giving you a bit of a hint every time you get to a synthesis or a mechanism problem. I'm telling you how many steps I'm expecting, and I'm telling you how many things I'm looking for in the synthesis. Truth be told, on the unit tests, I normally have to cut this in half, so the number of points is equal to like half the number of steps, and that's because unit tests are not worth a lot of points, and some mechanisms are a lot of steps, so I have to scale it down by some amount. What I'm trying to do here with mechanisms and synthesis is make it incredibly clear how you're going to be graded so that it doesn't feel like any confusion, so that you're not getting points back and saying, What did I even do wrong in this synthesis? What did I miss in this mechanism? Where did all those points go? I don't understand any of it. Trying to make it as clear as possible where those points come from. What else do you want to talk about from the syllabus? What else was important to mention? What else was missing?
Can I ask something about like the written work?
Yep.
Are you like, is that something like we have to print off, or is that like, can we like make a PDF of it and like?
Yeah, so it's already a Word doc and a PDF.
And like we can like
Download it, annotate it. You could print it if you wanted to. I've also had people that just have a separate piece of paper and they just show their work on it. They don't copy any of this down. They just show their work and then upload a picture of that. Super flexible there. Not trying to make this more complicated for you than it needs to be. Just trying to make sure I have a chance to give you feedback. How about attendance? You guys know my attendance policy? It's mandatory for the midterm and the final, but I'm not going to be checking other than that. I'm trying to record lectures. I'll post them to Canvas and YouTube, but this is not a hybrid class. It's not an online class. So if there are technical difficulties, I hate to say it, but then there will be technical difficulties for that day. I actually already have recordings from my summer and my fall lecture series. They're on my YouTube channel. There's a link to that in my external resources and on the lecture recordings page. So look for, also if you feel like I don't explain something well during a specific lecture period, try to find that same lecture in a previous semester. I never say the same thing twice. I always say it a little bit differently. So if you thought I said it confusing one day, try to find it from an earlier semester, and I'll probably say it differently in that video. How about some expectations for the class? Are you guys okay with cell phone use in class? Do you feel like that's a decision I have to make? I would say no volume on your cell phone and nothing distracting to your neighbors. So if your neighbor looks distracted by what you're doing, I might tell you to stop, but you should probably realize that and minimize your own distraction. But otherwise, be on your phones if you need to be. I would not have stayed awake for all of Calc 2 if it were not for playing games on my phone. So if you want to sleep in class, sleep in class. I'm not going to be offended. We're sleepy people, so get your beauty rest in. I'll consider it, I'll take it as you seeing this as a safe place to sleep. Food, I'm okay with in class as long as it doesn't smell too delicious, because then I might get hungry. It is late, so feel free to eat, just don't be loud or making us want to steal your food. Oh, I also have a grade replacement policy in my syllabus. I take either your final course grade or your final exam score, whichever is higher. So if you don't do well on the final, it gets factored into your final grade as it normally would. If you do great on the final and you outpace how you did in the course, you get that grade for the course. That's because it is a final exam. So if you show me that you did better on the final exam than you did all semester, great. That's how well you did at the end of the semester. If you didn't do so hot, then it just gets factored in as part of your 30%. To qualify for that, you need to submit all of your assignments, because I'm looking to see that you learned throughout the semester and then did better than that on the final. But if you missed unit tests and if you miss homework and if you miss quizzes, you're not showing me that you learned throughout the semester and exceeded that on the final. You're just showing me that you didn't work throughout the semester and then showed up for the final. So you have to qualify for that by turning everything in. I think that's a fair requirement. All right, during each class, since we're here for 2 hours, I do like to give you guys a chance to get up and move around. So why don't we take advantage of that now? Take a 5-minute break. We'll come back at the 4. Get up, stretch, find the bathrooms, find the water fountains, and we'll come back in to talk a little bit more. Oh, I'll take your sheets. Thank you. Thank you. Thank you. Thank you. Thank you. Appreciate it. Thank you. Thank you. Thank you. Thank you. Ooh, just in the nick of time. I wouldn't have known you otherwise. Thank you. Thank you.
So I also have 3 cats.
Yeah?
Wait, I have a question. So when you want us to put our name, you want us just to put like what you want to like call us, or like what our name as in like our like full name?
If those are 2 different things, maybe put both and circle the name you want to be called.
Okay.
I mean, do you think that you are going to get mixed up with somebody else by your name?
I mean, well, I don't know. I don't know if there's another name in this class. So.
I don't think there is, actually. I think you might be the only one.
Okay, so I'm just gonna
That works perfect. Thank you, James. Who did I miss? Oh, Sarah. Thank you. You guys know the best way to get an A? Tutoring. But don't misunderstand me. It's not just going to tutoring. It's tutoring. Teaching somebody else. So those people you already talked to today, maybe you should get their phone numbers. Start a group chat. Message them on Canvas. Ask them if they want to join you at the STEM Center upstairs after class so that you guys can work on assignments together and study together. The best way to learn this material is to teach it to somebody else. And that might feel like, how am I going to know if I'm doing it right or not? That's okay. Just take a stab at it. You'll start realizing what you're confident in and what you're not. So get to know each other. Work together. I had an OCHEM 2 class. It was in this room before it turned into this. There's so many TVs in here. There's a TV back here too. Why aren't they on? Shouldn't they have this? I don't know. What was I going to say? Tutor each other. I had a class in this room, I guess it was a year ago. They were all on this Discord channel. Every last one of them, even the ones that didn't talk much. And they posted about class like every day. Roasting me, roasting the homework, roasting the unit tests. But I'll tell you what, nobody missed anything. They were all on top of it. They knew when stuff was due. They knew how to solve problems. They had a really strong group. So get a small group, get a big group, get whatever group you can, and give each other chances to teach each other. Some of you might feel like the weak link in a group. Good. Raise your hand to teach the other people, because if you think they know more than you, then they'll be able to correct you when you make a mistake. If you feel like the strong link in a group, good. Stay quiet. Listen for what you know is right. Listen for what you know is wrong. Yeah. Okay.
That's all I gotta say about that.
What?
It's like you're doing a Forrest Gump, but like, that's all I've gotta say about that.
I don't know that line from Forrest Gump.
Please don't tell you've never seen Forrest Gump.
Life's like a box of chocolates. You never know what you're going to get. Unless they have the names on the top, and then you can actually pick the ones you want to get. Those are the best chocolates. Must have been after his time, huh? Anything else from the syllabus from the class you guys want to talk about? Sarah?
You did allow test corrections last semester of the midterm. Are you gonna allow that again?
I am. Every semester I'm like, maybe I will, maybe I won't. I'll see how it goes. I've decided already. I give bonus points. I have opportunity for bonus points on my exams. You have to earn the points. I look for your understanding. But they disproportionately go to the people that already do well on the exams. So I've thought about taking them off of the exams, and every time I bring that up to a class, everyone's like, no, no. Even the people with test anxiety are like, leave them on there. They're not making me more anxious. I'm already anxious. The test corrections that I allow, I call a midterm exam analysis. So you get your midterm back, and you get to analyze the questions you did wrong to earn back up to half of the points you lost, which doesn't include the bonus points. So if you did really poorly on the exam, you can earn a lot of points back on the midterm exam analysis. If you did really well on the exam, you can't earn that many points back. So the bonus points and the exam analysis disproportionately help different demographics in the class, and that's my goal. That's what I'm looking for. So I'm going to keep it. You guys will have the chance to analyze your midterm. It's not just to give you points back. It's not just to right that wrong of who gets bonus points. It is also to solidify your understanding. I give you your exams back no matter what. This is my way of incentivizing you to study, to master those concepts you missed on the midterm so that you don't miss them on the final, because the final is cumulative. So those things you missed, they're coming back. Those of you that took my class in the fall, did it work? Did the exam analysis help you do better on the final on those concepts you missed? Cool. Good. Maybe it didn't. I don't know. Maybe I should stop doing it altogether. But if it does help, that's good. Usually I see it does help. And I will say, I don't hand out bonus points. I look for learning. So with the midterm exam analysis, if you analyze it wrong, I don't give you points for that. If you analyze it and you miss the mark a little bit, I might give you partial credit for the work that you did. I'm looking for learning, which is why I also don't give out extra credit for being a part of clubs. I don't give out extra credit for going to events. I don't give extra credit for just submitting things. I look for the learning in it. There is one other bonus opportunity that you guys will have throughout the semester. That is on these PLO assignments. These are program learning outcome assessments. As a department, we want to track all sections of a course and see how all students in that course are doing across all sections. So we need these baseline assessments that every section is doing. The problem is with our organic classes, everybody teaches a little bit differently. So these are not my assignments. These are our course lead picked assignments. They don't look like the assignments I give. They don't look like the questions I ask. You're not going to see any questions that you're graded on that look like this. But you can earn bonus points that go to your homework by doing these assignments. And again, I'm looking for learning, so you don't just get full 10 points for turning it in. I actually go through and look to see how you did, because again, we're trying to assess how our students are doing throughout the semester. You're not penalized for not doing it. It's worth 0 points, but it literally can't hurt to do it. But because we are using it as an assessment, I only allow for 1 submission. Once it's graded, you can't turn it back in for more points, which is kind of a bummer, but it's the way it's got to be. These are not spread out. Those of you that were in my OCHEM 1 class, the assessments used to be spread out throughout the modules that they were relevant to. These aren't spread out. They're just kind of up here in their own module. And that's because they don't really fall in a good place. So I would say start them early and come back to them often. See if you've learned anything else that applies to them. The last thing that I want to talk about is actually this analysis of an organic compound. How many of you that did this before actually liked it? Okay, that looks like most of you that did this before, so that's good. Not everybody, but that's okay. Those of you that have done this before will need to do a new compound. There's no analyzing the compound you did last semester. I want you to pick a compound that's relevant to you. If you're going into medicine, maybe pick a compound that is relevant to medicine, pharmacy, veterinary science, dental. If you work in a certain job and there's a chemical that you want to study, that's a great place to do this. Now, there are some requirements that you won't necessarily know how to follow. They involve the reactions that we're going to be doing in the semester and whether they're applicable or not to your chemical. So if you submit one and it doesn't really line up with the reactions we're going to do, I might just tell you no, resubmit. Or you could submit 3 and say, this is the one I really want to do, but this is my first backup, this is my second backup. And then I'll say your first choice doesn't work, but do your first backup. There are some requirements. It's got to have at least 6 carbons, and it's got to have at least 1 non-hydrogen element. I'd be surprised if you found a compound that is relevant to you that only has 1 non-hydrogen, non-carbon element. We're going to be doing different assignments with them. So looking at their IR spectra and then doing a synthesis with the compound and doing a synthesis that makes your compound. These assignments are all worth 1 point, but they are yes or no, all or nothing. So if you submit your IR predictions and you missed 1 single peak, 0 out of 1 points, I'll tell you to look in a specific spot until you find it and resubmit and earn the points. All or nothing, it's mastery based. It's meant to be a challenge, but it's not meant to be impossible, yeah? And again, I can throw compounds at you all semester long, and I will. But this is a compound that you picked, which means that it's going to be more meaningful to your learning to apply our chemistry knowledge to that compound because you picked it. It's your fault. I mean, it's you did it. I think it's fun. I really enjoy these assignments. I learn a lot by what you guys submit throughout the semester. All right.
Do you have like any example compounds on the initial one?
I do right here. I say that I chose cellulose. In general, I don't recommend polymers. Polymers are chemical structures that have these repeating units because in theory they can go on forever. It can be really hard to propose a way to make that or propose a reaction with it. But I've had people use polymers before, and I just say, imagine you're dealing with a selection of it and ignore the rest. So you're definitely welcome to use this as an example. Yep. Okay. Any last questions you guys have from the course? How things are going to go, what you should expect?
I might have stepped out when you said this, but I was just wondering on the unit tests, since they're online, will there be like tutorials monitoring it?
Only if you want it. No? Okay. I hate Lockdown Browser. In general, I think prohibition creates avenues to get around prohibitions. So I try not to prohibit your whatever you're trying to access by making you be on a lockdown browser. I'm already encouraging you to use your notes. I'm already discouraging you from using the internet, but I'm not going to make you sit there and use that lockdown browser. It's a pain for me, it's a pain for you, and I don't think it's going to improve your score on the unit tests. Again, the risk about cheating on the unit test is you're going to do worse on the exams. So if you want a good grade in the class, put your all into those unit tests. Yeah, good question though. Anything else? Magnets? Those are for my little talk. I want them back. Those were a Christmas present. Isn't that such a nice Christmas present? Yeah. Those of you that have been in my class before know that I bring in these strings that have magnets on them, and we use them to wrap our curtains. My partner got really sick of me bringing in our curtain wrappers for class, so he bought me magnets for Christmas. It's better than coal. And the benefit is you guys get to hold on to those magnets for the whole talk. You don't have to pass the magnets around. But those magnets are kind of central to this mini lecture that I want to give you guys right now. So if you guys don't have any more questions. I'll tell you what, this little content creator mic gives me more anxiety than anything. I miss just having my laptop pick up my voice, but this is doing a much better job. And my mic is the laptop, so from here I'd be shouting. I've found myself shouting a lot less too. I just talk at a normal volume. Is it harder to hear in the back? I guess you're not that far away. All right. I like awkward silence. So you guys don't have any last questions?
Why does the mic give you anxiety?
Because, like, what if the battery dies? What if it's not connected? What if it's just picking up static? I've had it happen too many times where the software I use to record my videos, for some reason the mic was, like, turned off. And so it didn't record audio the whole lecture. I gave a talk on chirality. And so I was like, you see the clock and how it's doing this and now it's doing that? One of my strongest students wrote a letter for her to get into med school. She got in. She missed that day and she said, I watched the recording and I couldn't hear anything, but boy, you were visual enough that I understood exactly what you were talking about. No, the whole system gives me anxiety, but like this added component to it just makes it that much scarier. When I first started teaching, I tried using those cameras that are in the classrooms. But those only connect to Zoom, and Zoom does a really bad video quality recording, and it saves the recording for 6 months. That's it. And then it erases it forever. So I stopped doing Zoom.
But I just one question. Like, if we try to join, like, if we have to miss a day, but we try to join via Zoom, can you accommodate that for us?
It's hard to, because maybe. I have a second laptop. I maybe could set it up. But it's just easier for me to post it to YouTube and to Canvas. And because you'd be on Zoom, I wouldn't really be looking to see if you had questions, you know? So like your ability to engage in the class would be hindered anyways. I think it would be just as useful to be watching the recording. But we can talk about it. Bring it up if ever needed, okay? All right, so I want to talk to you guys about the 4 fundamental forces. Those of you that have had me before have heard about these, but they are named the fundamental forces because they are fundamental to our universe. The first that I want to talk about is gravity, which is by far the weakest of these 4 fundamental forces, and arguably not a force. Now you experience gravity. You're experiencing it right now. It's what's keeping you in your chairs instead of floating up to the ceilings. And so this experience of gravity not being a force is hard to understand because it's such a reality to us. Newton says that gravity is a force acted on each other by 2 objects. The earth is pulling on you, and you, to a very small extent, are pulling on the earth. Einstein says that your mass is warping space-time, and the Earth is curving space-time to a much larger extent than you are. And so you are moving in a straight line through curved space-time towards the center of the Earth. And it feels like a force because the stuff beneath you can't move. So you're being pulled through space-time against solid material that's not moving, and you've got to stand up against it. So arguably not a force, but something that we definitely understand as a force. So talk to me about some things that experience gravity. Could you paint the picture of what experiences gravity in one word? Maybe not one word, a few words? Everything? Everything with mass. Can we talk about everything with mass? What has mass? Matter. I think arguably mass and matter are two sides of the same coin. To have mass means that you are made of matter. To be made of matter means that you have mass. So I agree. Can we give any other terms to it? What has mass? Protons, electrons, neutrons. We're not going to be representing a lot of protons or neutrons, but what does that plus, negative, and 0 indicate? That's its charge. You know, I had a student get towards the end of OChem 1 and tell me, oh, I kept thinking the positively charged molecule had an extra electron. I associate positive with electron. Oh, that's not good. But it happens, I guess. So I'm just here to remind you, protons are the particle that brings a positive electric charge. Electrons bring that negative electric charge. Neutrons don't bring any charge. Protons and neutrons bring about the same amount of mass. Electrons, in comparison, have no significant mass, but they do still have mass. So is it true that things with mass experience gravity? Yes. Is it only things with mass that experience gravity? No. Light is manipulated by gravity as well. Sometimes we'll represent light in this course by h nu, which is Planck's constant and the frequency of light. We know that light experiences gravity as well because of the event horizon of black holes. Light can't escape the gravitational pull. We also see gravitational lensing in space. An incredibly dense galaxy in our line of sight will have a galaxy behind it whose light is curved through that curved space-time around that gravitationally dense galaxy. It will show up at our space telescopes in more than one spot because its light has been warped through curved space-time. Very cool. All right, those are our fundamental components: protons, neutrons, and electrons. The next force I want to talk about is the strong nuclear force. This takes us to the other end. This is our strongest of the four fundamental forces. This is essentially what holds together our nuclei. What is nuclei? Plural, center of an atom. Nucleus, center of one atom. Nuclei, the centers of multiple atoms. Here's a nucleus that you should all be very familiar with. This is the hydrogen nucleus. What is its nucleus composed of? No. 1 proton. Because protons and neutrons bring the same amount of mass, H1 is denoting the mass, which is 1 proton. So this is 1 proton, which means the H1 nucleus actually doesn't involve the strong nuclear force at all. There's an isotope of hydrogen called deuterium, H2. H2 has a mass of 2, but because it's hydrogen, it still has just 1 proton. So this is 1 proton and 1 neutron. What is holding that proton and neutron together is the strong nuclear force. The reason that those two particles don't drift apart is because they're held together by the strong nuclear force. Let's scale it up a little bit. Here's another set of nuclei that you should know about. Carbon-12 is the most abundant isotope of carbon. Carbon-13 is an incredibly useful isotope in nuclear magnetic resonance spectroscopy. Carbon-13 is not very abundant in nature, but it is NMR active, so we can analyze carbon atoms by looking for carbon-13. How many protons in carbon-12's nucleus? Good. Because it's carbon, we know that there are 6 protons. How many neutrons in carbon-12 nucleus? Also 6. Protons in carbon-13? And neutrons in carbon-13? Good. Now, inside of that nucleus, there are 6 positively charged particles being held very close together. Does that seem odd to you at all? Don't positive charges repel? Don't nuclei repel because nuclei are positively charged bunches of matter? So if positive charges repel, why are they not destroying this nucleus? Strong nuclear force is holding them close together. The strong nuclear force, the strongest of these fundamental forces, is stronger than the electromagnetic force that is repelling those positive charges from each other. All right, the next force I want to talk about is the weak nuclear force. This truly is not going to come up ever for us, and I don't have a good way of explaining it. It's just weird. It has to do with the quarks inside of the protons and the neutrons, to my understanding. So here's an example of the weak nuclear force. When you have nitrogen on Earth, the most abundant form of nitrogen, nitrogen-14 isotope, can be hit with radiation from space and turned into carbon-14. All right, what's inside the nucleus of nitrogen-14? How many protons? 7 protons and 7 neutrons. How about carbon-14? How many protons? 6 protons because it's a different element. 8 neutrons. So what has happened in this process of nitrogen-14 becoming carbon-14 is that a proton has been converted into a neutron. That involves overcoming the weak nuclear force. Do you guys know what carbon-14 is useful for? Carbon dating. That's because the only time nitrogen can be converted into carbon is when it's exposed to the atmosphere and exposed to that radiation. So a living organism that has nitrogen or is breathing in nitrogen that has been converted into this carbon-14 accumulates that carbon-14 in its bone structure or in its bodies, in its minerals. And then that carbon-14 radioactively decays. Again, the weak nuclear force is involved in that decay process back from a neutron to a proton. So it's not really useful to us. We're not going to explore the weak nuclear force. But again, it kind of highlights our isotopes and our nuclei. Here's where chemistry really takes place. Oops. Electromagnetic force, otherwise called electromagnetism. You hear two things in there, don't you? It sounds like an electric force, electricity, and it sounds like a magnetic force, magnetism. They're the same force. They're not different from each other. Two different experiences. You're feeling a magnet right now. You're feeling that pull that those magnets have on each other. If you flip them around, you have to fight the repulsion that they have. That is electromagnetism. It's no different than electricity. Or I should say that they're intertwined with each other. Here's the core of electromagnetism. When you have a particle that is charged, this happens the most with electrons. It's less relevant to protons, but it does happen. And when this charged particle spins, imagine a ball that's spinning, but it's not a ball and it's not spinning. That's an electron. It creates a magnetic field. So you have this electric charge, and we should say like charges repel each other. We talked about that in the nuclei. Positive charges, in theory, repel each other, but the strong nuclear force can overcome that. These negative charges should repel each other, but if your electron that is spinning finds itself adjacent to an electron spinning the opposite way, that's not the opposite way, is it? The magnetic field of the electron spinning opposite is pointed opposite. So despite being like charges, they're basically tiny magnets that can attract each other. You've heard of electron pairs? Why do electrons pair? They're magnets. They're pulling each other in to stabilize each other. So this also helps us explain why electrons are attracted to protons. Opposites attract. Much like how similar ends of a magnet repel each other, and opposite ends of a magnet attract each other. These charges repel and attract each other, but magnets are made up of those charged particles. The magnet doesn't exist unless there's a charged particle to spin to make it. So the magnets you're holding, I don't know what they're made of. Let's say it's iron. That iron is made of its nuclei and the electrons surrounding the nuclei. It's those electrons surrounding the nuclei where one of them is unpaired, a leftover magnet with no buddy to counter it. Each iron nuclei has one unpaired electron, creating its own little magnet around that iron nucleus. All of those nuclei together have a cumulative effect of all of those unpaired electrons. All of their magnetic fields combined together, you've got this large macro scale magnet that you can feel. Now scale that up to the size of Earth's core. If you have a chunk of iron in the middle of Earth, all of those atoms can align their magnetic fields to create a magnetic field that extends well beyond the circumference of the Earth. Earth's magnetic field is a result of individual spinning electrons inside of the core. Another application about this, right here, electrons are pulled into protons. This is what gives us the electron cloud surrounding our nucleus. Those electrons are pulled in towards the protons. Why is it they never hit? Well, these are all very, very small things. And so the odds of them finding each other and running into each other is just very small. But they're pulled in because of this. This is the size of our atom. It's mostly empty space. Here, in this tiny dot, is the mass of our atom. Most of the mass is stored in a very small place. Most of the size is empty. It's weird, but it's because of the electromagnetic force. This is all chemistry is. Atoms are just interesting magnets. Some are weak, some are strong. You ever had a magnet that you stuck to your fridge and it just slid down because it wasn't strong enough? Some atoms are just weak magnets. You ever had a magnet you stuck to your fridge and you couldn't get it off because it was too hard, too strong? Some atoms are strong magnets. Some atoms will bond very strongly. Some atoms will not bond strongly at all. Sometimes you need to put in a lot of energy to break a bond between those little interesting magnets. Sometimes you don't need a lot of energy at all. Chemistry is all about the electromagnetic force. There's another part that I didn't get to, but I do want to let you guys go, and that is that light is electromagnetic radiation. Light is the force carrier for electromagnetism. So you can have light interact with both electric and magnetic fields. You can create electricity. You can move electrons using magnets. I charge my phone every night on a magnetic charger. It induces a magnetic field that pushes electrons into a higher energy state. They're two experiences of the same force, which is about the exact opposite of gravity. One experience that is not a force at all. So I want these back. Don't leave with them. I'll find you. But I want you to hold this analogy with you all semester, that when chemistry starts to feel hard, just remember you're just playing with magnets. That's all that chemistry is. Thank you guys. Have a good night. I'll see you on Thursday for our first real lecture of the semester.
Oh, are like, is the